This is chapter 12.4, using the law of sines to find angle in side measures. And for this recording, we'll be actually just finding the angle measures. Okay, for day one, we did page 672, 3 through 5. And for day two, we'll be doing, again, 672, but this time 15 through 20. On page 669, the checkpoint activity, we are given this information. In triangle ABC, A equals 20, B, capital B, vertex B, angle B is 25 degrees, and angle C, or vertex C, equals 40 degrees. So that's your capital C. And we need to find side B. So we need to find the length of side B. So if we're finding side B, then we need to have sine of B. And if and we already know side A, so we need to have sine of A. So using the law of sines, sine angle A over A equals sine angle B over lowercase b. Now we're just going to go ahead and substitute in those values. So the sine of A, we don't know yet, but we do know what A is. A is 20. Sine of B, so that's angle B, is 25 degrees. And we don't know what the length of sine of 25 degrees is what I meant to write. Sine of 25 degrees. And we don't know what angle or side B is yet, so we're going to just write B. But we can find A, and here's how we find it. We know that any triangle has three interior angles that measure 180 degrees. If you add those three angles up, you would get 180 degrees. Well, here we only had two angles, 40 degrees and 25 degrees, which is 65 degrees. If I subtract that from 180, then I get 115 degrees. That's this angle right here. So angle A is sine 115 degrees. Now you don't need your calculator yet, but you will shortly. Anytime you have a ratio equal to another ratio, it is a proportion, and proportions can always be solved using cross products. This is a great algebraic way to solve proportions. So we're going to have sine 115 degrees times B equaling, again, you're just multiplying across diagonally, and that's going to be your means and your extremes. Then you're going to have 20 times sine 25 degrees. And then we've got the next step. We're not going to solve anything on the calculator yet. The next step is going to be to isolate B. So in order to isolate B, this is sine 115 degrees times B. So to isolate it, I need to divide by sine 115 degrees. If I divide one side using the division property of equality, then I have to divide the other side by the same amount. So dividing 20 times the sine 25 degrees, dividing that by sine 115 degrees. All right, now, sine 115 degrees divided by sine 115 degrees leaves us with 1. 1 times B is B. And now we are going to have B equals 20 times sine 25 degrees divided by sine 115 degrees. Now when you plug this into your calculator, I want to caution you, if you don't close the parentheses on the sine 25 degrees, you will get the wrong answer. So you go ahead and plug in 20, hit your times key on your calculator, then your sine button, 25, and it's in degrees. Your calculator's set to be in degrees. Close the parenthesis, now hit your divide key, and then sine 115 degrees. Now if you don't close that parenthesis, it won't matter, but you might want to just get in the habit of doing that anyway. Then hit your enter key, and you get this big long number. We're going to go ahead and round it to the nearest hundredth, and so B is going to be approximately, once I round, it's not going to be exact, 9.33. So it's going to be approximately 9.33. Now I want to add a little bit more onto that. So 9.33 is the length of B. But if you look at B, you can also see that B could also be written as AC. So if you look at your triangle, your picture of your triangle right here, let me get an eraser so you can see it better. You can see that B is also this AC right here. So if they were to ask you to find segment AC, you still could. B or segment AC. So again, it's just to have you make a little bit more larger connection than if I just say B. So if they asked you for the length of AC, you would be perfectly able to find that because you can find the length of B. Okay, we're going to do another extra example. So if you were here for day one, this example is already written down. If you were not, go ahead and copy it down into your notes. For day two, you're going to go ahead and copy down this example. Okay, so this is going to be an extra example. It's not in your book, but I would like you to write it down. The problem says, find the length of C given that A is 94 degrees. That's angle A, or the vertex A. C is 67 degrees. And the side length B is 25 degrees. Well, if you have a 94-degree angle, you know it's obtuse. Not by much, just slightly beyond a right triangle. That's probably even too much. So almost straight. And then you know that the other two angles are going to be acute, because that's what has to be true. If you have an obtuse angle, the other two angles have to be acute in order to get 180 degrees. Now let's see if we even need to find the other angle, but we'll go ahead and label it ABC, because it's going to be an ABC triangle again, ABC. We know that angle A is 94 degrees. I purposefully put the A there because that's my one obtuse angle. Angle C is 67 degrees. And then we don't know what angle B is, but we know that B is 25. Let's label it as B equals 25. Well, we are going to need it because we need to have this angle here to go with this B. So let's go ahead and write down the law of sines. So you're going to use the law of sines. And the law of sines just says if you take sine B divided by B, you can set it equal, or it is proportional to, and you know you're trying to find lowercase c, that's the length of side C. Your angle C is 67 degrees, so sine C over C. And so in order to find out what B is, because we will need that information, we would go 94 plus 67, which is 161. And we take that away from 180 degrees, which is the measure of the three interior angles of a triangle. And that's going to give us 19 degrees. So angle B is 19 degrees. So sine B is sine 19 degrees. Side B is 25. And then sine C is 67 degrees. And it's over the side C. Now let's go ahead and put that C in. Here's your vertex C, so directly opposite that is going to be your C equals. Okay, so we're going to put the letter C here. Now we are going to go ahead and use cross products. So it's going to be sine 19 degrees times C equals 25 times sine 67 degrees. We are going to isolate C, so we're going to divide by sine 19 degrees. Sine 19 degrees divided by sine 19 degrees is 1. You're left with C, which was our goal. And now we're going to actually plug into the calculator to find out what C is. The buttons you'll push will be 25 times. You'll push your sine button, type in 67, close the parentheses, hit your divide button, then you'll type in sine 19 degrees, and you'll end up with 70.6844 and so on, which you will round to, so it's going to become approximately 70.68, because we'll go to the hundredths place, and that is the length of side C. And if you look at C, C could also be referred to as AB. And so C is approximately, it's not exact, 70.68. Okay, now make sure you have enough information between your other notes, the classwork we did, and these two examples to be able to complete the assignment. I've already checked off page 672, 3 through 5. And the second part of this assignment will be page 672, 3 through 5. And the second part of this example will be page 672, 15 through 20.